Hello folks, welcome to Global Coding Cohort. I hope all of you went through all the previous portions that we learned. Uh, by yesterday, I thought I planned to finish teaching this basic Python, but, but 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 as I failed to finish it yesterday, today let's try to finish it. Okay. I hope my voice is audible to all of you. If there is any audio or visual issues, please let me know in the comments. So yesterday we stopped at the mm, time complexity, isn't it? Okay, time complexity. So from that we understood that we have to achieve the task in less maximum possible less number of maximum we should try to achieve our task with a minimum number of loops, minimum number of iteration. So because based on the loop we are calculating the time complexity. Got it? Uh, the reason why we consider uh, every line that is it is with every line that is within the body as a constant because for example if we have x is equal to a plus b, then we couldn't optimize it further. It will take that time by default. It is designed to use that particular time. If we want to do that operation in our computer, then it will surely take some time, which is by default same with the design of the programming language and the interpreter working of the interpreter itself. Got it? So that's why we cannot touch that time, but that time is constant always. So when will it increase means when we have different loop uh, over the same piece of body, then time get increased gradually, isn't gradually or exponentially, whatever based on the scenario, we are calculating it by using time complexity. So in short, we should try to achieve our target within a minimum number of loops. The same for the same task, we can also give different solution, which is a bit more costlier than this, obviously. But after writing all the solutions, we should choose the best one. Which one? With the very less time complexity. Got it? Very less time complexity in case of measuring the worst case. In the worst case itself, if our algorithm, if the solution is performing good, then that algorithm is considered to be better. We should not avoid the best case as well, as the yesterday I explained you about it. So that scenario is also we should also take in consideration of best case scenarios, but majorly, most importantly, we should focus on the worst case because once if your algorithm performs better at worst case, then it is assumed to work better at the other case, most in with most of the other cases. So similarly, today let's start seeing auxiliary space. This calculates the space requirement of our space RAM required to execute, so RAM or memory required to execute our code. Not the total memory, but the rate at which it changes. In time complexity also, the case is not the total time, not the wall time, not the clock time. We are not calculating that. We are calculating the rate at which it is possible for the algorithm to increase depending on the input size or n value. Got it? We are trying to determine the rate at which the time or space gets increased depending on the time. Sorry, depending on the input. Understood? Okay. I hope all of you understood this. Let's see few examples. Space, absolute space. This is also represented using three cases: burst, average, and worst case. And majorly we will focus on the worst case performance because same like in time complexity here also, if an algorithm using is performing better even in worst case scenario, then that an algorithm is assumed to perform better in other scenarios as well. Got it? Better means in case of auxiliary space, here how the uh, how our algorithm uses the memory, the rate change, the rate of change of memory usage. Got it? So let's see an example here. Uh, let's take a file I less than n equal to 0, right? Plus, sorry, right? Plus equal to I. So in this scenario, our while loop gets executed for 5 times, but now we are focusing on the storage, isn't it? The space that is occupied. Here it's constant, irrespective of the input value. I will remain, I's value will be changed, but its size will remain same because it hold only one number, isn't it? And the same is applied here. N will also hold only one number. So in this case, though the time complexity of this code is O of n, the auxiliary space of this the auxiliary space of this algorithm is O of 1. Understood? Oh, sorry guys, this much time I have spoken without sharing my screen. Okay, okay, I'll share it now. Okay, as we didn't go much, as we didn't go much, it is easy for me to repeat all things that we said. Okay, today we are learning auxiliary space. Yesterday, I hope all of you heard the story which I told this. Okay, so uh, okay, in this code, our n is 5. Though this code runs 5 times and its time complexity is O of n, that means when n is 5, this code will run for this code means this code means the body that is present within this while loop. Okay, so as this code runs for 5 times, we say the time complexity of this code is O of n, because when we give 10, this will run for 10 times. Got it? But when we calculate auxiliary space, we just have n here, and n always, what irrespective of the value it holds, it is holding one number, isn't it? And same with the case of I. It is also holding one number at a time. Its size is not getting increased depending on the input size. Got it? So here within the body also, its size is not getting increased. Only the value is just getting changed. Whatever may be the value, the size is going to be constant throughout the program. So throughout the execution. Got it? So that's why we will we will say the auxiliary space of auxiliary space of this algorithm is of n. Sorry, so of 1 because it's not getting changed. But let's see another scenario where I'm giving n is equal to 5. Let's consider a temp list equal to an empty list. Okay, then for same, let's use the same while loop I less than n. I'm going to append I to 10 for it and I plus equal to 1. This loop runs for 5 times and its time complexity is 5. But the auxiliary space is also n because when we give 5, this list is going to grow. When this code executes, the size of this list is going to grow. So therefore, that means we are appending values, right? We are going to append values, isn't it? Yeah, let's see. Initially, or no problem. Let's print at each iteration print ln of temp. At each iteration, you can see the length of temp. So what's happening here? N is equal to 5, I less than. Oh, okay, got it. I is not initial. So now we can see these are the length of this list temp. You can see it's growing at each iteration. In each loop, this list is getting the size of the list is getting increased. Got it? The size is growing. So at each iteration, it is growing with 1. But so totally, when we give 5, the list grows till 5. When we give 10, list grows, the size of the list goes up to 10. So therefore, we will say this algorithm's auxiliary space is of n. Understood? Okay. Now let's move to the, please note it down. In the meanwhile, write it in a way that you understand so that you can revise it efficiently later. Okay, now let's move to the next topic. In the meanwhile, we take notes. Okay. So completed. I hope all of you completed. So let me tell you. Let me summarize once again the topic that we learned. So in time complexity, we should try to a good coder should try to achieve the task given to him or her in a very minimum loop. Minimum loop means the code will run faster. And next factor is a good coder should write a code which uses minimum memory. Understood? Okay. Next topic is recursion. Recursion. Uh, in our previous sessions, we learned looping, isn't it? Just before also we saw looping. Let's take a scenario. Before we understand what, before we see what's recursion, let's see, take a scenario. I'm going to print uh, 10 to 1. Reverse 10 to 1 in reverse. Correct. Greater than or equal to 1. Understood. So using while loop, now we printed 10 to 1 in a reverse way. In recursion, how we will do this means, first of all, let me tell you what is recursion. Recursion means, for example, let's consider there is a, let's assume place by force, interpretation. Okay, had some trouble with my drawing tablet. That's why I took something. Okay. Okay. Now let's see recursion. Recursion. What if, let's assume we have a function called mm, something, some sample function. Okay, some function. So what is this line? We have some function over here. Dot dot dot. Okay, we are calling the function now. Okay, now we are assume that we are calling the function now. This way we executed one time, isn't? If you we are user is calling it. Okay, user is manually writing a line like this and calling it. Understood? So, but the case with recursion is this function itself will call itself repeatedly until based on the condition that we until it gets false or till it is true. Until the time it is true, the condition is true, it will continue calling itself. It will call itself like someone talking on by seeing the mirror. Okay, it's a similar scenario like this. For example, I am talking to myself like that. The function will call itself until the condition becomes false. Or we can say in another way, it will call itself until the condition remains true. Or we can say in this way, two ways are there. We can tell this in two ways. Function calls itself until the condition becomes false. Or another second way of telling this is the function will call itself until the condition remains true. Correct. In both ways, we can say both delivers the same meaning. It will call itself, okay, repeatedly till the condition become false. So, any idea of how to do this task using recursion? No problem. I will show it to you. If you don't know, no problem. I will show it to you. Okay. Now let's write. reverse. Let's write a function called rev. Let's take argument n. Argument means we can look at that also as a parameter or argument. Okay. We are placing an argument n. Then we are printing. Our task is to print, isn't print 10 to 1, isn't it? So I'll print n, then call again myself. Myself means it will call itself. But if it's just simply write like this, when will it stop calling itself? At some point of time, we want the function to stop calling itself, isn't it? So we have to mention if n reverse, we are going reverse, isn't it? So n greater than equal to or greater than 1. Okay, we will fix it later. Okay, until this condition is true, it will call itself. Now let me give it 5. So it called itself from 5 to 1. Understood? What happened means, how this code works means, I'll show you. Okay. First, at this place, we are giving 5, isn't it? First then is 5. It will print that particular 5. It will print 5. Then what it's doing? As the current n is 5, isn't it? 5 is greater than 1. So it will call itself. So again, then reverse 5. Now, while calling, I am decreasing n with 1. And so I'm subtracting n with 1 and passing that particular value. So if I reduce 1 from 5, what is the value? 4 will go here. Understood? So now this call, now rev 4, in rev 4, when current n is 4, it will be printed, and now it will check again if this 4 is greater than 1. Yes. So calling it again, what will be called? The current n is 4, isn't it? So 4 minus 1. What is 4 minus 1? 3 will be called. Current n is 3 will be printed. Condition will be checked. Yes. So it is true. Yes means true. Okay, that is what I meant there. Now the current n is 3. The next call, n will be reduced with 1 and will be called current n is 2 printed. Then again it will be checked. It is greater than 1. True. Again it will be called, and now it will become 1. Current is 1 and it will be printed PRT. Okay, printed, that will do. Just simply I'm writing roughly. Okay. Then now the condition checks. Current n is 1, isn't it? Whether 1 is greater than 1? No, the condition is false over here. So hereafter it will not call. Understood? This is how recursion works. Got it? So take notes. Now let's see a small comparison of its total time, wall time. Okay, how something is performing. For loop for I in range, I want to print 10 to 1, I And the next cell, let me write another code while I equal to 10, I greater than or equal to greater than uh, greater than equal to 1. Find I minus equal to 1. Then next line, sorry, next cell, another scenario. The same, okay, the same scenario. The same scenario also in three places. A row of 10. Then row 10. The wall time might get changed over time. That's based on the load of your system. The time may get changed. It will not be constant always. So you can try when you try it yourself. You can just run a particular cells at least 3 times and take an average or maximum or minimum of better. You can just go with the average of 3 times that you get from a particular cell. Okay. Any guess which will perform good? If you have any guess, just type your option for or while or recursion. Guess which will perform, which will run in less time, which will be fast. Say your answer in comments right now, and let's check it if you are right or not. Just it's a guess, just for fun I'm telling you. Okay. Okay. Now let's see. Now let's execute itself and see it's done. All time. Execution time. It took new second means microsecond. Okay. 137 microsecond. While loop took 1.39 millisecond. This took 13 microsecond. And this took, sorry, not 13, 100 microsecond. This took 324 microsecond. And this will keep changing. 137, okay, 137. For the first time, we got 137. Let's run it one more time. So average, we will take it 50, okay, or 50, not even 50. Let's have this 71 itself, okay. For average, as an average, 71 microseconds. Microsecond means is denoted by mu s, okay. Millisecond ms and nanosecond ms. Got it? 1.39 milliseconds. Second time. Uh, so 51 microseconds. Let's take it an average of 200 microseconds. Or one more time. Let's take. No problem. Let's take 50 microseconds. Then this one. First we got 100. Now it is okay. Let's as an average. Let's take 110. Okay. That's because okay. I will show you this and we'll explain about that later. 47, 48, 47, 48. Why the time here is 141 and here we get double digit number? What's the difference? Why? Because here that this time includes this method is getting created, right? That time is also included. Here the method calling time. When real time, only once the method will be created and this call alone will be done in different places or recursively. Okay. Only this call will be done repeatedly. So the calls time is 47 microsecond, which is less than all other loops. In most of the cases, recursion works faster. This is what we are able to understand from this small analysis of execution time of different three types of loop. Got it? Recursion is also a kind of tool. Okay. I missed to teach it teach this concept before. That's why today I took it. So that's why even if you miss something else, we will learn as we go. Okay, in the upcoming sessions. Then now let's uh, yeah, okay. This code will be there. You can find this code file in my GitHub repository. I have given the link for the same in the description of this live. Tomorrow onwards, we'll be uh, solving different kinds of problem statements, coding questions. Okay, and you can, if you have any questions which you faced in your interview or anywhere, you can just, if you feel like you want a solution for that, you want help to solve that, you can just post that question in the link I have given in the description. I have given a link to for a Google form where you can submit your problem statement either as a screenshots or as a text. But make sure that you should have, along with problem statement, you should have at least two input and output samples. Got it? Now let's see the next concept, regular expression. This is also a fast executing filter, right? This will filter things very fastly than we just filter like using some other if condition or whatever. In other ways, this way of filtering text is faster than other ways. Right? So rejects, we will also call this as a reject. Okay, regular expression. So for this, we have to import. We missed one more topic. Okay, let's quickly finish this and see that also. Okay. Uh, there are different ways of taking input and output and writing output also. Okay, we just saw only print as a output in the output segment, and we saw just input of method to get input. We also have other ways to get input also. Got it? I will show it to you today itself. Let's finish this up quickly. For the regular expression, uh, uh, let's import the library that Python provides. Then let's have some text over here. Uh, this is first feature. We can using regular expression, we can search for any particular word, whether to check if that word is if that word is present in this given string or not. The string is present in 10 base. So let's try to check if a particular word. Let's search for apple. If apple is present here, not string. We have storing the string in 10 base. So we have to do 10 here. Got it. Now let's execute this line. Yes, there is a match, so we got this output. If there is no match, sorry, no match means, okay, let's give some other banana. If there is no match, it will return none. Okay, it's true, isn't it? Because it's returning none. Okay, to cross check and make you understand, I have used this condition over here. Okay, it returns none if there is no match. If it has match, then it will return. Even if there is spelling, it's partially present, it will return. But if you give something like this, then it will not match. Okay. If you give APP, it will match. But if there is a word APPE, no, there is no word called APPE, isn't? So therefore, a continuous sequence of letters will be matched. Understood? It's uh, working. So now let's see. Let's get at this in a variable called match. We have to know, isn't it? We are searching means we should get to the location of it, isn't? So we are going to get the location of it. Match.start, match.end. This will return from the index location of it. The apple is present from, okay, no problem. I will pass this inside 10 so that you can see apple returned over. Sorry, not apple. You just gave only app, isn't? So app is present in from this index location to this index location. Got it? This is what is present inside this. You will get index. Index will be returned. Not it. Take notes along with me. Okay. Today we will take extra few minutes because we just today I remembered that we missed one more thing also. So I will cover that concept as well. Next, now we have this is an apple, isn't it? Okay. Let's leave that. Let's leave it a second. Let me put a full stop here. Read out search of r dot dot. If that is present, sorry. It's what will dot do means dot will take anything. If there is any uh, character present over there, then dot will return that. Let's check in this place. Let's have one. Even now, what dot assumes is it should have something over there. Oh. Okay. Okay. Now I will not show this start and end. Here you can understand that. I will just I'm trying to show what will this dot do over here. Got it? And in some cases, we will have to if you want to give some special meaning to dot, because this is a punctuation also, isn't? If you want to give some special meaning, then you have to give something like this. That means if you want to mention this dot as a punctuation, then you should give this backslash so that it will return the location where it is present. Understood? else if not, it will just dot will just check if some character is there present over there. Got it? So as we have T at first, it is returning T. If we have some other thing, then that will return T as a match. Got it? Next, with the same example, let's try to okay, let's check it's working. Okay, so first of 5 letters. So let's try that. What's it? Read. Okay, we also have A over here, but as we have A at first, no, small letter isn't. It is checking for small letter. Okay. Now what I am trying to tell you is what will this square bracket doing? This square bracket is doing, this is called a class. Uh, if you want to mention something, some range of things, then we can probably use this square bracket and mention whatever we want. So in this place, mm, okay, I'm giving A to E. That's why it's returning where it's first where it's finding this lowercase a. But in the same case, scenario, let's see another scenario. Sorry, A to E, A to E. Then in this case also, though I give both uppercase and lowercase, the first present value is lowercase a. So that's why it is returning this one. If I just give uppercase A E, okay, let's let this scenario be here. I will make it in next slide so that you can find different scenarios of its working. Now we can find the apples A is getting matched. Got it? This is how this range, like this class works. Things present in this is how things present in class works. Now, okay. This much time we use search isn't. Now let's use another function called match. Re dot match. Let's pass the regular expression. Now we are going to learn caret symbol. Caret. Okay. This caret symbol. What's our example? We our string starts with this isn't. So what this caret does is it will check if something is starting with th. Starts. It checks if some word is starting with th. So there is something starting with th. That's why we got it matched. Now let's see if something is the is not present there. So okay, let's update this example. Okay, uh, let us have simply the also, but still it is not returning. Sorry, still it's not returning. It isn't because it it will check only if some string starts with the value that we pass over here. So caret checks if the value present after this is present at the starting of any string. Got it? Caret checks only at the start of the string, and it will try to match if the value passed over here is present there in the string in the beginning. It will check only if this value is present in the start of the string. Got it? Take notes along with me. We will be seeing different small these like changes. Let's see now dollar symbol. So dollar symbol, you can use this in more than match, right? Why it's not returning? Actually, this should check if some if some string is ending with a value that we give over here. Got it? We have a string called the, but still it is not returning. I will check it later and will inform you, okay, about this dollars in the earlier expression. In any one of the upcoming session, I will share about this information, okay. Right now, let's skip this dollar symbol. Let's now move over to the next one. Dot match, dot match. Mm, okay, let's move with A, B itself. A, B. What's its meaning means? Uh, if any one of the letter represented here is present over here, then it will return the match. For example, A, B, B, A. Something is present over there, isn't it? A, C. Some value is present. Any one of the value is present in this relation. If it will return as matched, it will return the match if any one of the letter present in this is available in the string to be checked. AC is the string to be checked. As we have A over there, it's getting returned. Even if we have CA, sorry, something should begin at first, okay? Should be present in the starting of the string. So CA, it will not work, but for AC, it will work. At the same time, for BA, it will work. BC, it will work. Got it? And CB, it will not work. Understood how it works? BC, let's have two scenarios so that you can easily track and understand. The next symbol, what does this means? For AB, it will return. And even if this A is not present in B, this will return because this how this will work means this will check this will match even if this value present before this question mark is present or not. Whether this is present or not, this will match. At the same time, if we have something like this, why am I writing it from the beginning? Let's copy it, right? In this case, okay, mm, if you are having set B, then it will not match. Understood? That is it. That is its difference. And then re dot match. Next one, or for example, let's have a of curly brace of 1 to 2 means 1 to 3 means it matches. Till this 3, it will match. And if it means A is present. If A is not at all present over here, then it will not match. Okay. But if we put 0 over here, then it will match. But if we put, sorry, as we have 1 over there, it will not work. And even if we have 2, this will work. Even if we have 1, it will work. It will work means it will match. Okay. So we are giving the count of A within this curly brace as range. Okay. 1, 2, 3. 1, 2, 3 means not just 1, 2, and 3. 1, 2, okay. For example, okay. 1, 2, I'll give it 1, 2, 5. It will work till 1 to 5. Got it? It is not the numbers 1 to 5, the range 1, 1, 2, 3, 4, 5. Got it? Okay. Now let's move to next. RE. Let's now use a new function find all the regex slash w, sorry, slash w. Let's use the stem bucket. So what this does means it will take all the, okay, we need not use stem, we will use another example. Okay. Time is 11 a.m. Just for an example, this will take all the words as letters. If we give plus, it has left the, you can I can see observe it has left the space in between. It has taken only those characters, not the space. Got it? Only letters and numbers are taken. When we give plus over here, this plus, what do this plus do means? It will combine the words. So here we have time is 11 a.m. and we got it split it like this. Okay. With the same example, we give just D, then numbers only the numbers are taken. But at the same time, if we give D plus, then plus will combine those numbers and will return it to us. Numbers means there is a digit present in the string. Understood? In this, using this expression, you can filter even a big paragraph. You can filter content which you need. Understood? Shall we now solve a small example? Uh, Let me have, okay, something called my email, my or Gmail, Gmail ID is n001 at gmail.com. Let's consider this as a string. Now I want to extract only those email IDs that is present in this string. Got it? So in this case, what will I do means I will search for regular expression. I'll search for the regular expression. Okay, first let me finish the syntax. I'll write something like this. I told you the specialty of this square bracket isn't because uh, there there can be any number of some range of letters. It isn't. Some IDs may have capital letter. I don't know. Just assume that I don't know what kind of melody is present in this thing. But there are possibilities that melodies can have capital letters in their name. Isn't this part? So I am giving that possibility. Then by default, most of the melodies will only have small letters. So that part, not A to E, but A to Z. Okay, A to Z. Then A to Z. Then we will have various punctuations that I told you to import string and get punctuations. Punctuations, and these are all the punctuations we have. Let's copy that, paste it here, and I can have all these things. Then what else? What else is a possibility? We can also have numbers, isn't it? So I'll give 0 to 9. 0 to 9 means almost all numbers are covered. Now let's see. We are constructing an expression to filter the mail ID present in the string. Okay. Now let's see what happens. It's returning nothing. But what is the structure of our mail ID? We also have an at there. And then we have gmail.com. Using this, we can consider this as a separate one. We can separate those with rounded brackets. Okay. If we have, because this is the string that we will have in, we are going to take the Gmail IDs, isn't it? So mail IDs, Gmail ID. So Gmail IDs will have this. They have this. Surely will have this string, isn't it? Only unless and until it is not a Yahoo or some other domain names. So we just our task. We just need to filter all the Gmail IDs. Isn't it? So we will give this within the rounded brackets to separate it from the other steps. And we have given punctuations over here, but at the same time, we know that uh, in this particular mail ID, we just only have uh, letters and numbers. Isn't it? We know that. mm, let's do something like this. Why is my arrow not working? My keyboard is doing some trouble with me. Guys, there is some trouble with my system. I'm facing some trouble with my system. Okay, it's not with my system, it is the browser. Okay, it's with the Firefox. So when I restarted, it got fixed. Okay, fine. Now in our case, we just have this particular mail ID, but it's matching just the one to at gmail.com. But why is this doing like something like this? We have another symbol called star. So if we give star, the previous thing, this will be, for example, L is matched under this class, E is matched under this class. So we can have any number of this kind of letters. That is what the star is mentioning over there in the expression. Got it? So now we got our complete email ID here. But now our full task is not over. In my case, I don't have any punctuation marks over there. But even if we have or not, we should get it, isn't it? So how I gave means what is or doing? This symbol, this particular symbol does. Here just before we saw, isn't, where do we saw? Uh, okay, here. Even if A is present or not, it will match, isn't it? So in our case, in my email ID, I do not have any punctuation, but somebody else might have, isn't it? So this will match with their structure also. For example, let's assume I just have Lekshman dot or Lekshman MJ dot 001. Let's assume this scenario. Now it is not working. So that means we have to fix something also. Mm, let's take it. It's not natural. We should try different ways how we can extract this. Okay, about how we can extract this. Zero to nine. Then A to Z to Z. Oh, this is also not good. Dots can come anywhere. Let's simply have uh, a dot over here. Let's try it. After that, let's add other punctuations. Obviously, email IDs will not have that number of punctuations. Mostly only dot will be there, right? Let's simply have dot. Okay, now it's working. Now it's working. Mostly email IDs will not have any other symbols, right? We will just have in the username part, we will just have dot or underscore. Beyond that, we will not have right something other. Another. Okay, when we gave full form punctuations, some things have been taken as a separate because I have told you right. The problem that we faced is because I told you this dot while explaining this dot itself. If we do not give, if you want to make this as a see, I want the location of this particular full stop. But when I simply give dot over there, then that's getting the by default meaning, the default default meaning that this regular expression has isn't. So here in the regular expression, we have separate meaning for closed bracket, curly brackets, and this backslash we have different. But when I paste this complete when I pasted this complete punctuations, then those different things also got some meaning over there. So that's why it didn't come. So here I specified to give a meaning of to give this a meaning of full stop. I gave backslash isn't. So in our case, to filter a mail ID, it is enough to give just like this. So this will select all those stuffs present, all those different varieties of email ID that is present in our string. Got it? So if any one of you have any doubt, I can start a Telegram meeting so that you can directly ask your doubts to me. If any one of you have doubt, please comment uh, yes, have doubt in some comments so that I will start Telegram meeting. If there are not any comments, I will consider that the, you have understood this concept clearly. So I see no comments coming. So I consider all of you understood this. Okay. Mm, okay. I told you I will teach you one more concept, isn't? Let's see it today. Let's see it today itself. Shall we say it tomorrow? Oh, okay. Already it's 1.5 hours we had. Okay, no problem. Let's see it tomorrow. I will after teaching that. After because we missed the two other two types of receiving input and output. Uh, so you will see that ways of getting input and output tomorrow at first, and after that, or once after we complete that, we will start solving different problem statements. Okay, so that's it for now, guys. So make sure to like this live and share this with your colleagues. Help us help this community grow. And thanks for watching. See you tomorrow. Until then, bye bye.